This presentation on hot mix asphalt paving inspection covers the highway construction personnel who inspect hot mix asphalt paving operations. The objective is to help both new and experienced inspectors in performing the duties and responsibilities necessary to ensure that quality HMA pavements are constructed for the state of Michigan. Hot mix asphalt paving inspection is divided into 4 parts. Part 1 begins with a general overview. It includes basic information about paving, and then covers equipment requirements in detail. Part 2 looks at service repair work and other paving preparations, such as traffic control, joints and crack repair, and bond coat applications. Paving operations are presented in Part 3. Covered in detail are mix delivery, pavement courses, paving procedures, inspections, and other topics. Finally, Part 4 covers joint construction, compaction requirements, rolling principles and procedures, coring for density acceptance, final surface checks and pavement markings. Throughout this presentation, the focus is on inspection, what your duties and responsibilities are in ensuring that the work is done properly and the results are acceptable. This completes the general overview. Next, some basic information about paving mixtures, plant operations, and contract documents. HMA paving mixtures consist of performance-grade asphalt binders, aggregates, mineral filler, and possibly other additives. Variations in the gradations of aggregate and in the percentages of asphalt material and aggregate content result in different mixes for the different courses that form hot mix asphalt pavements, base, leveling, and top courses, and in the mixtures used for HMA shoulders, approaches, and hand patching. All these mixtures are produced at hot mix asphalt plants, where the component materials, the batching, and mixing equipment, and the production itself are carefully monitored. From the plants, the mixtures are hauled to the road, placed in courses by the paving equipment, and rolled by compaction equipment to construct the hot mix asphalt pavement. The entire operation must be done according to the requirements of the special provisions, supplemental specifications, project plans and drawings, standard plans, and standard specifications. If there are conflicts among these documents, the order of precedence should be as listed here from 1 through 5. In the rest of this first part of the course, we'll look at hot mix asphalt paving equipment and cover the requirements. The equipment includes distributors, hauling trucks, a material transfer machine, pavers, rollers, miscellaneous equipment, and inspection tools. Before construction begins, all of the contractor's equipment is expected to be in good working condition. In general, equipment should run smoothly, perform the intended function properly, and have no fuel or oil leaks. Now let's look at the equipment individually, starting with distributors. In hot mix asphalt paving, a pressure distributor is used to apply liquid bituminous materials, bond or tack coat. A distributor is basically a storage tank mounted on a truck. The bituminous material application rate, the amount of material that's applied to gallons per square yard of surface, depends on both the speed of the truck and the spray pressure. MDOT's bond coat application rate should be between 0.05 and 0.15 gallon per square yard residual binder to provide minimum adequate bond material. Both should be held constant to produce uniform coverage. In the trucker's cab, you'll typically find a computerized control unit that controls the bond coat application rate. For the truck to maintain the uniform speed required for proper application, it must be equipped with an accurate control unit that's calibrated to indicated speed and feet per minute, as well as gallons per minute to ensure minimum application rate of 0.15 to 0.015 gallons per square yard. A positive displacement type pump is required to circulate the HMA material in the distributor's tank. Spray it through the spray bar or wand and draw it back into the tank from the bar or wand. This circulation system has to be able to distribute the bituminous materials uniformly at the specified rate. Distributor trucks shall be calibrated yearly. The distributor's heating system must heat the HMA material uniformly and safely to the specified temperature and maintain it at that temperature. Propane is the heating fuel typically used. It's carried in tanks equipped with pressure gauges. This particular distributor has a thermometer that shows the temperature of the HMA material. It's housed in a well on the distributor. Other distributors have dial-type thermometers. The distributor's spray bar is required to be full circulating and be operated in application widths from up to 3 to 24 feet in 1-foot increments. By opening and closing specific nozzles, different spray widths are obtained. Spray bars are also adjusted vertically to increase or decrease the distance between the bar and the surface being covered. Distributors are required to have various sizes of nozzles available, from 1/8 inch to 1/4 inch. Whatever size is used, they must have instantaneous shutoff with no dripping. Complete bond coat coverage is accomplished when the entire pavement surface is 100% covered with at least the minimum application rate. To produce the required uniform fan spray, the nozzles can be opened and closed, and they can be angled. Nozzle adjustments are covered in detail later in this presentation. In some areas, bituminous material may be applied through the spray wands. It's used for applying material along curb and gutter, along existing pavement edges, adjacent to concrete structures, in small and isolated areas, as well as for small patches. Distributors should have a sampling valve or tap from which samples can be taken. Finally, 2 items related to safety. First, distributors should be equipped with a working backup alarm. On projects where traffic is maintained, distributors must also have at least one flashing, rotating, or oscillating amber light. The light has to be mounted so that it will be visible to traffic in both directions and operated constantly while work is in progress. Next, the trucks. They haul units that transfer the hot mix from the plant to the paving site. To begin with, they must have tight, clean, and smooth beds. In addition, the mixture discharged from the hauling unit should be at the target placement temperature specified. Each truck must have an adequately secured cover of the size and material to completely protect the mix from the weather and to retard the escape of heat so that the mix doesn't cool off or crust over. Michigan law requires all trucks to be tarped. Trucks also should be equipped with and use a backup alarm as per state law. When required in the proposal or specified in the standard specifications, when paving the uppermost leveling and top courses, the contractor must use a material transfer device, MTD. This system independently delivers the HMA from the truck transport to the paver hopper to assure constant paver speed, remixing HMA material using manufacturers' developed technologies, and depositing material in the paver hopper without stopping the laydown operation. Provide a paver hopper insert with at least a 10-ton capacity in the paver and keep at least 1/3 full of mix during paving. This MTD operation is using a RoadTech machine. Now pavers. We will look at a couple of types of paving machines while we talk about features and requirements common to all types. For specific details, consult the Service for Operators Manual for the paver used on your job. First, hot mix asphalt pavers have to be self-powered machines, able to spread and finish the mix to the desired cross-section and grade. They must be designed so that the supporting wheels or tracks ride on the prepared base. All pavers consist of two main units, the tractor unit and the screed unit. The tractor unit powers the paver and spreads the mix on the roadway. It consists of several key parts, including the engine, push rollers, receiving hopper, feeders, flow control gate, and augers. The paver's engine has to provide the tractor with a smooth, steady pull on the screed unit. Additionally, the electrical system must be in good condition to supply the proper voltage to the paver's automation equipment. The two roller bars at the front of the paver are the points of contact for the truck wheels. To properly push the trucks forward, the roller bars must be in a free turning condition, not gummed up with hot mix asphalt material or otherwise damaged. If the paver is equipped with a truck hitch, it should work properly. Truck hitches are designed to latch onto the rims of the truck's rear wheels to maintain contact between the paver and hauling unit. Just behind the roller bars is the paver's receiving hopper. It holds the mix after it's unloaded from the trucks and supplies a continuous flow to the feeders. The rubber retaining shields attached to the front of the hopper should be in good condition to keep any mix from falling out and if the hopper is overfilled. In the bottom of the hopper are two feeders, or conveyors, that can be operated in various speeds, together or separately, to move the mix for the tractor unit into the spreading augers. To carry the mix to the augers, some pavers have feeders that pass beneath the control gates at the back of the hopper. These can be raised and lowered together or separately to regulate the amount of mix that passes through. Now for the screed unit of the paver, the unit that strikes off, partially compacts, and smoothens the mix. The screed is attached to the tractor by two control arms, one on each side of the paver. The control arms are attached in such a way that the screed floats on top of the mix being laid, leaving a smooth, even surface. Hydraulic cylinders raise and lower the control arms as they are activated either manually or automatically. The whole screed unit can be raised for the paver to travel, maneuver, and lowered to the position of the pavement. In automatic grade control, basically, the hydraulic cylinders raise and lower the control arms, changing the angle of attack and the slope of the screed in response to signals from the automatic controls. A manufacturer-approved grade referencing attachment is required to send grade signals as it rides along the surface, adjusting the screed automatically. The automatic controls can be set and maintained at a particular transverse slope, or the slope can be changed as necessary in transitions. The transverse slope is referenced off the grade side of the machine. Pavers typically have a slope box or other indicator showing the slope of the screed. Some pavers have gauges indicating approximate mat thickness, but remember that these are not very accurate. Yield checks and depth measurements are normally taken to determine the correct mat thickness and application rate. For HMA mix to flow smoothly under the screed, the leading edge should always have slightly more crown than the trailing edge. The amounts of crown are checked by running a string line along each edge and measuring from it to the screed surface. The leading edge and the trailing edge must be set according to the contract documents, usually flat and to the planned slope of the project. To strike off partially compact and smooth the mix, screeds must work with a vibrating, more oscillating action. You'll need to ensure that the paver on your job operates with a proper screed action. Pavers must also be equipped with properly working screed heaters. 3 types are used: electric, hot oil, and fuel burners. These heat the screed to the temperature of the mix before paving begins. Before construction begins, verify that the heaters work properly. When paving widths are wider than the main screed, extensions are used. On some pavers, this means attaching extensions, while on other pavers there are built-in sections that can be extended hydraulically. Screed extensions have to be equipped with a continuation of the automatically controlled spreading augers. The augers must be extended to within 12 inches of the outside edge of the screed's edger plate. Screed extensions must be able to perform exactly like the main screeds, as far as vibration, heating, and slope and grade are concerned. But there are areas where the extensions are set independently to provide different slope, such as to pave a valley gutter or tapered joint. In place of pavers, self-propelled mechanical spreaders, also known as road wideners, may be used for shoulders and widenings. These machines have to be able to place the mix to the proper width, depth, and slope without segregating. They may be used for base course mixtures for shoulders and widenings less than 10.5 feet in length, and for top and leveling course mixtures for shoulders and widenings less than 8 feet in length. A couple of thoughts about safety. The warning decals attest to the need to be careful when working around pavers. The great variety of heavy, hot-moving parts can pose real danger to those who get careless. Features such as safety locks for screeds for control arms should be used when appropriate. Where traffic is maintained, pavers must have one flashing, rotating, or oscillating amber light on each side. Be sure the lights are visible to traffic in both directions and are operating continually while the work is underway. Night paving requires adequate lighting around the paving operation for safety and proper inspection checks. Next on the equipment list is rollers. Their purpose is to compact the HMA lifts to required density and to leave the surfaces smooth and even. There are both steel-wheeled and pneumatic tire rollers. The steel-wheeled variety includes a 3-wheeled static and tandem static or vibratory. Regardless of the type, all rollers must be self-propelled. The steel-wheeled have to be smooth and free of openings or projections that would mar the paved surface. The rollers must have a water sprinkler system and scrapers to keep mix from sticking to the roller drum. The steering must be responsive and permit the rollers to be directed on the desired alignment. Vibratory rollers must have a shutoff to deactivate vibrators when the roller speed is less than 1/2 mile per hour. They also must have a way of locking in the manufacturer's recommended speed, the vibrations per minute, and the amplitude of vibration for planned application rate or dynamic force for the type of HMA mixture being compacted. Pneumatic tired rollers have to be equipped with at least 7 wheels arranged so that the gaps between the tires of one axle are covered by the tires of the other axle. In other words, the rear tire cannot follow in the tracks of the forward tires, but must be staggered. In fact, they must be spaced so that there will be a minimum tire path overlap of 1/2 inch. The tires must be smooth, no treads, and capable of being inflated to the manufacturer's recommended pressure. The tire pressure must not vary more than 5 pounds per square inch between individual tires. Pneumatic tired rollers have to be able to reverse smoothly, free of any backlash or wobbling. The rollers must have scrapers or mats and be equipped with skirting to enclose the wheel areas to within 3 inches of the pavement surface to prevent the mixture adhering to the tires. For safety when traffic is maintained, each roller must be equipped with at least one warning light that's visible to traffic in both directions. Nighttime operations must have sufficient lighting, as covered in the special provisions or standard specifications, to allow the workers to clearly see and perform all nighttime work and for the inspection of these operations. There are several items of miscellaneous equipment that the contractor must provide. While these are not as big or complicated as the other equipment, they're still essential to a successful paving operation. Basic hand equipment includes lutes and shovels for working the mix, and 10-foot straight edges for checking the smoothness of joints and other surface areas of the pavement. Hand brooms are useful in cleaning the surface before and after paving. Also power brooms and vac-all trucks. For traffic control, advanced warning signs, arrow panels, cones, lighted drums, Type 3 barricades, and other devices, as well as radios, are all necessary tools on the typical paving operation. Your inspection tools and equipment include the job proposal, standard and contract plans, and standard specifications book readily available, along with such items as tape measure, 4-foot or longer carpenter's level, 6-foot rule, putty knife, string line, and air and surface thermometers. The equipment used in hot mix asphalt paving must be in good condition and be operated properly to produce the desired results. This concludes Part 1, General Course Overview, Basic Information, and Equipment Requirements.